Hello guys, a very happy morning to every one of you. And now we are just going to see the manufacturing technology. This about the non-traditional machine. So in the previous chapter, I just explained each and everything about the ECM and how the ECM is working. And a little bit of extra details also I just told in my previous chapter. Okay, previous lesson. So as we are just continuing the next thing, and we are after continuing each and everything, we'll go for the next information. It is next topic. Okay. So we will have just 2 minutes of discussion, and then we can just go to our classes. Okay, it means non-conventional process, nice strength. It means harder steel pneumonic alloys, and generally we just see about the material removal and tool. Here tool hardness will be so much high, and the material hardness doesn't depend, only the melting temperature depends. Okay, whatever the tool hardness, it is whatever the material hardness, we don't consider the bottom complex, very high accuracy, and there are only 4 types of thing. One is thermal energy method, and electrochemical method, and chemical energy method, and mechanical energy method. Okay, so in thermal energy method there are only 5 types: ion beam, electron beam, laser beam, and electron discharge. It means electrical discharge, laser beam, plasma arc. Okay, so next one electrochemical grinding, electrochemical deburring, electrochemical lapping, and electrochemical honing. So chemical method only one type, so chemical misting method, that's it. But in mechanical energy, after 3 types: abrasive, water jet, it means water jet, and abrasive, water jet, ultrasonic. Okay, so this thing I just told. Okay, EDM has highest efficiency, but ECM has the highest material removal rate, and USM and AJM are having low material removal rate. Okay, so definitely, and there non-metal, generally ultrasonic and abrasive jet is used for non-metal machining. Okay, laser beam and electron beam has higher penetration rate with lower material removal rate. Okay, electrochemical. Okay, chemical manufacturing PCB. So shape cutting ability is micro drilling. So micro drilling we generally go for it means not ultrasonic, it's the electron beam and laser beam machining, cavity sinking, and standard hole means electro discharge machining, and standard hole means electro discharge, and UCM it means abrasive, it means ultrasonic machining. Fine hole means ECM. Okay, electrochemical machining, and rapid cut, signature everything, plasma arc, shallow piping, AJM. Okay, abrasive jet, shallow pocket. Okay, so here the material should be electrically conductive. Okay, when it is electrically conductive, you can just do. Okay, and as I just told about each bit of anything, so here ionic displacement will occur. Okay, each and every ion displacement will occur, and each and everything. Okay, so next, what is the material removal rate? It is in 2 types. One is gram per second. Okay, one is gram per second. Next one is centimeter cube per second. Okay, it's most important, centimeter cube per second. Okay, EF divided by rho of F. Okay, EI material removal centimeter cube per second is EI divided by rho of F. Okay, so next one, if gram per second means EI divided by F, that's it. Density won't come at the bottom, so mostly convert to centimeter cube per second. It means centimeter cube per second, and you just calculate. And suppose if they just given it means density, so much density means 100 divided by density equal to summation of x1 divided by density 1 plus x2 divided by density 2 and x3 divided by density 3. Okay, if the same thing goes for the E of equal. Okay, it means what is the unit of E? E is gram per mole. Okay, E is gram per mole, and the farad coulomb is coulomb per mole. Okay, coulomb per mole. Coulomb goes under the category of which one? What is the unit of coulomb? Coulomb is ampere second divided by mole. Okay, this one E is gram per mole, and this one is ampere second divided by mole. Okay, current each and everything I think so you would have known. M is mass. Okay, from this you can calculate each and everything. Okay, suppose if material removal rate for alloy is given, E equivalent I divided by rho of alloy of F. Okay, and each and everything we just see about according to Faraday's law. EDM I just told, it's about melting and evaporation aided by cavitation. This thing is mostly aided by melting and evaporation. The process is based on melting temperature, not hardness. Okay, so hard material can be machined this way. Okay, so the hard jump sequence 1 to 10% is thing I think so you don't know, and voltage is this one. Okay, least resistance definitely. So dielectric fluid expands and takes out each and everything. And here you can see the electrical conductivity and low. It means our electro discharge machine, definitely here tool wear will occur. So that way we are just considering wear is equal to volume of work material removed divided by volume of tool metal removed. Okay, this is the most important thing. Okay, dielectric fluid servo mechanism, dielectric fluid I think so you don't know, and dielectric fluid quick corrosion based oil we just use. Okay, these are the circuit, and there is a two type of thing. One is a discharge voltage and another is a normal voltage. Supply voltage also there, discharge voltage also there. So okay, so while you are just seeing the problems, you will get a clear cut of understanding. Okay, so we can just start our problems. Okay, next is this metal removal equal to electrode into feed rate. Okay, this is also one of the most electrode into feed rate. Okay, electrode feed rate into area. Okay, F into of area. Okay, this is also one of the most important thing. So you can just directly see the problem. A circular hole 25 mm, diameter 25 mm, depth height is 20 mm, EDM. Okay, and the metal removal rate 4 into 10 power minus 4 IT 1.23. I is current is 300 ampere. It means which one? Temperature is 1600 degrees Celsius. So the time required for measuring the hole. Okay, they are asking the time. So what is the basic formula? Just one sec. Okay. So you can see here time is given. TC equal to RC. It means the resistance of capacitor ln V0 by V0 minus of VT. Okay, but we don't know the time, and suppose we can just also make like this. Okay, V equal to V0 1 minus of V of T by RC of C. Okay. What could be the possible? Okay, metal removal. Okay, EDT. Okay, the time. This one wait, interesting. So here each and everything is given as millimeter cube per minute. Okay, so we need only time. So 4 into 10 power 4 current into T minus 1.23 millimeter cube per minute. So equal to, so what is the thing? Metal removal rate is feed rate into of area. Okay, so they have just given area of circle. Okay, circle area. Or what could be the thing? Millimeter cube. Okay, then here millimeter cube per minute only should come. Okay. So definitely this side volume should come. Okay, volume into volume divided by time means it will be a far more good thing. Okay, so now 4 into 10 power 4 I is 300 into 1600. It means how much it will come? Minus 1.23. It means this will be the metal removal rate. So metal removal equal to which one? Volume. So volume I just think so. It means metal removal rate will come some answer millimeter cube per minute equal to this side the volume. Volume is millimeter cube. It means pi by 4 d square of h. They just haven't given again of this thing, so that's why. Page number 13. So mostly divided by time only will come, I think so. So it means equal by this one divided by t. So Just wait for 2 seconds and make sure you will get the right answer. So just a normal thing only, as I said before, you can see it will simulate each and everything. We will just calculate and we will just put here. Here it's been given 1000, okay, but here it's been given 1600. It's not a okay. So just put here and we will get this one, okay. So next thing you can see this one time. So just equate middle demodulate into t. T is seconds. You can see this one is entirely okay. Just make it equal to time and you can do the answer. Okay, that's it. So you can just go for this one. So in EDM and process using RC circuit, it's a relax circuit. A 12 mm diameter through a hole is made up of steel plate of 50 mm. Okay, 12 mm diameter is made. Okay. Resistance. So they are asking time for 1 cycle, okay. So what is the thing? It's resistance, supply voltage is okay, discharge voltage is 110. So VD is V0 1 minus of E of minus T by RC of divided by C, okay. C is the capacitance, okay. Here each and everything we have to just equate in a normal way, okay. Now put the answer. So VD is 110 equal to 220. 1 minus E is E minus T. We have to just find RC is 40 ohm into 20 into 10 power minus 6 farad. Okay. So if we just calculate, so here put ln, this also ln, okay, and make ln 110 divided by 220 equal to 1 minus of E of minus T by this one. So you can put ln or you may not also put ln, but everything the answer will come to you, okay. Within 2012 production, okay. Yes, correct. So we have to just equate in energy now. It means E in definitely in the E the answer will be given. It means the thing question itself, question not in the calculator the E value is given, so we have to just take that and we have to multiply. So second one, this one you can see power input, they are asking the power. So part of the power equal to energy divided by, it means supply time, it means the charging time, okay. So it means this is a charging time for entire cycle. It means the discharge plus of supply time, okay, charging time for the entire cycle. Okay, so E is what? 1 by 2 C of VD square, okay. So 1 by 2 C is how much? Capacitance is 20 into 10 power minus 6 into VD is 110 the whole square. So calculate this one. So divided by time of charging is this one. So how much is time for cycling one charge is? So 0.55 into 10 power minus 3 seconds. Okay, this thing will come as joule. So joule per second is watt. So now we calculate and we get the answer. So we can just go for this question. This question. So what they're asking is sitting of incidence discharge VD is how much? 100 volt, and charging time is TC is 25 microseconds into 10 power minus 6 again. Wow. So power is 1 kilowatt. Capacitance how much? So power equal to energy divided by time 1 by 2 C VD square divided by time. So power is how much? 1 into 10 power 3 watt equal to 1 by 2 C is, we don't know, VD is 100 volt, the whole square. Every time is 25 into 10 power minus 6. Okay, we just calculate, we will get the required answer. Yeah, micro 50. Okay. So this will keep like this micro, and this one 10 power 4 will come. So 2.5 is the answer. Okay. So next you can just go for this one. So they are asking the frequency of pulsing in a die sinking and die. Frequency is this one, 10 kilohertz. So under the pulse of time period is 40 milliseconds. So duty factor is how much? The pulse of, okay, pulse of means suppose if discharge and pulse of, discharge pulse of. So first we have to calculate the discharge. So we have no pulse of, we just given 40 seconds, microseconds. So what is the charging seconds? So frequency is 1 by of TC. Okay, TC equal to 1 by of 10 kilohertz. Okay, 10 power 3. So charging is hertz. Okay, 10 what will be, okay, minus 4. So 1 microsecond. Okay, so duty factor is charging divided by charging plus of time of discharge. So 1 divided by 41, duty factor 0.0243. Oh, where we are doing the wrong thing. This one, okay, this one TC, okay, time record for charge. Okay, we did correct, but we did a wrong approach. So F is 1 by of TC is total charging time. Okay, this one is total, this one total cycle time. So 1 divided by TC is 10 into 10 power 3. So how much will come? It means will come around 3 kilohertz. Okay, this generally the equation given is in hertz, microhertz. Okay, microsecond. Okay, So how much will come? Hey, reach and everything is given in a wrong way. Oh, here how much it comes? Okay, 0 0 0 1. So this one, okay, let us leave this one. 0 0 1 means how much? Maybe 1 microseconds, or how much? 1 2 3 4. So 1 into 10 power minus 4. So 1, okay, 10 into 10 power minus 3. So 10 microseconds. See, just make sure how they just made this one. So next one is pulse on time is this one we can just calculate, but this one okay, but how they literally made this one, literally I am not aware of it. So let us suppose what is 10 power minus 6. So each and everything, it means the entire thing we have to just write in a microsecond. So okay, instead of writing in a millisecond, we have to write in a microseconds, I think so. Okay. Yes, it's my mistake. Okay, micro and milli, because I was a little bit confused. 40 into 10 power minus 6. This is microseconds. So milli means 10 power minus 3. Check. So this is entirely comes under the category of, it means how much? 10 into 10 power minus 3 milliseconds. 10 milliseconds. So okay. So convert this into milli. That's it. It means total TC is 10 milliseconds. So equal to TC plus of T discharge. So DC discharge 10 millisecond minus of 40, it means micro 10 power minus 3 millisecond. Okay. So see, the unit is being mismatching, so we have to just convert into microseconds. So if you just convert, it means 1 into 10. So convert this into 100 microseconds. So this one 100 will be minus of 40 TC. Okay, TC is 60. Okay. So duty factor is, as I just told about this one. So TC plus of TC plus of TD equal to 60 divided by 100 equal to 0.64. Okay. Milli and this one is quite interesting. Okay. We will just explain. So 1 divided by 10 to 10 power 3 hertz. Okay. So how much will come? 1 divided by 10,000. 1 2 3 4. Okay. So these are got the points. Okay. So this one will be entirely second. Okay. So 1 second equal to 10 power 6 microsecond. Okay. So it means 1 into 10 power minus 4 into 10 power 6 microseconds. So 100 microseconds. Simple question, but see how much funny thing it's laughs against me. So you can see this one, the electrolysis. So the energy is E is asking how much. That's it, the question is finished. Ah, so much shorter duration. This thing, it means voltage given 200, discharge voltage this one, and RC, it means capacitances 50 micro. So energy equal to 1 by 2 CD VD the whole square. So 1 by 2 50 into 10 power minus 6 to 200 the whole square. So calculate this one, we'll just get the answer. Okay, so now I'll just zoom a little bit. So you can see advantages. So what are the advantages for EDM? It means you can see hardness, toughness and brittleness of a material is so much easier. Okay, so you can see hardness, toughness and brittleness of a material has no problem here. Okay, however, sorry guys, it's hungry for me, that's why. Due to the EDM, it means we can machine materials that are too hot and brittle better machined by conventional method. Okay, this method doesn't have any kind of chips and burns on the wall because it completely evaporates, and cutting force is virtually zero. So very delicate fine thing we can just go. From the process dimension repeatedly and surface appeal is extremely good. In casting surface, yes, definitely it does better oil. It means better oil utilization. Okay, this improves dye life. Okay, for mostly generally for dyes and all we use this kind of things. Okay, next thing, only electrical conductive material can be machined. So that's non-metallic material as a plastic cannot be machined by EDM. Okay, non-metals can't be. And you can see electrode wear, definitely electrode wear and as well as the oversize, overcut are serious problem. Okay, a rehardened and highly stressed zone is produced on the work surface by heat generation during the machining. Okay, force is zero, but stress will be. Why? Because you can see while the discharge is occurring, it leads to bursting, sudden bursting. Okay, so due to sudden bursting, heat generation will be. Due to the heat, the stresses will be. Okay, perfectly squared, it means perfect shape squared corners. Okay, corners can be achieved by EDM. Okay, but by wire method you can do this is higher. Okay, high specific energy consumption about 50 times of conventional. Okay, when you compare the conventional machine, it's 50 times higher. Material removal is quite low. Yes, definitely. When you compare with the electrochemical method, this is quite lesser. Okay, EDM can be used for machining any material that is electrically conductive, including metals and alloys and most have a garbage. And EDM is generally for machining burn-free intricate shapes and narrow slab and blind cavities. For example, sinking a hole. So in this, most of the things is been used. And EDM is particularly used for dealing with internal cuts. Okay. This one is banking parts of sheets, cutting off rods of okay. EDM method, a small hole about 0.13 mm and diameter as deep as 20 mm. Okay. So diesel fuel injection nozzle is used by an aircraft engines, air brake valves and so on. Okay, yes, definitely true. Okay, next one is wire EDM, because I just told about so you can see the shining thing will be in the inside of the shining thing. You can see sparking. Wire will be okay. So you can see this is the wire. So simple only guys. So by using the wire we'll just cut and we'll just take each and everything. See like this, it will see this wire like, okay, this wire will continue to move on, just the coolant is been applying. Okay, I think so you got the point. So wire idiom is special form of idiom where the electrode is continuously moving wire. The thin wire, brass, tungsten, copper is being used. The electrode wire is this one only, so much minimum. DIN is what is used as dielectric. Okay. See wire idiom. So the process, yes, definitely the process much faster than idiom, normal idiom, and the process only is for manufacturing punches, dies, stripper plates, and this one cutting dies and intricate shapes. Okay. And geometrical accurate, yes, definitely so much accurate. So you can see for okay, so die sinking and ECM wire cutting process so much efficient. Okay, so next one you can see in ECM both should be electrical conductive. Okay, B is the correct one. Okay, wire and sample are both electrical conductive. Okay, EDM, okay, ECM, okay. Measure is removed by intermediate high frequency. If I discharge metals and evaporates, yes. Small measure, okay. Electrode discharge grinding. So same as the before thing, electrode discharge grinding. Spark produces this one. Graphite will be rotated with this thing. Acid grinding, okay, internal grinding. Grinding carpets and steel at the same time without the wheel locating. Okay. Grinding between metals fragile parts which are abrasive might cause fracture. Okay. No abrasive if graphite in workpiece to achieve short circuit will happen. Okay. I think so it is the mind. So the mechanism is avoided by melting and evaporation. Okay. It means which one? Electrode discharge, melting and evaporation. Vaporization. No force, yes, no force will be there. Okay. Copper is the best thing. As definitely high thermal conductivity should be, yes, and high specific rate should be, because high thermal conductivity means you can easily pass the heat outside, and high specific conductivity means it takes time to reach the higher melting temperature. Okay, that's it. Cool wear should be lesser and the remaining should be higher. Okay. Because it's a cavity. Okay. Only cavity sinking and standalone as is just all over EDM has been used. Okay. This one I think is silver tungsten and this one carbon tungsten. Okay. Dipole ring. Which one? Dipole is generally goes to tungsten wire. Okay. Fine hole is ECM and dipole is EDM. Just one sec. No, it's okay. So next thing we are just going to see ultrasonic machining. This thing generally has in the PE. Okay. This thing I think so you can easily do it. So anyways, I'll just explain this one. Tungsten machine. Okay. Oh, they are asking the material removal rate. Okay. The titanium sheet of 5 mm thickness. Okay. Is cut by, okay, 5 mm thickness. 5 mm thickness is cut by wire. Okay. wire diameter 1.0 mm, uniform spark gap, okay. So uniform spark gap of both sides of the wire, okay. So 0.5 mm is use the feed rate of the wire into the feed rate, okay. So feed rate into area, so feed rate is 20 millimeter per minute into area. So area of which one? Area of the wire, means it is diameter is given here. So pi by 4 d square. Calculate will get the answer. I think so. Let us see what will be the answer. It's been asked in 2009. Get P only. Oh my god, even in this question also they haven't given. Oh, such a. Oh my god, it's really so much shocking, guys. They haven't given here means. Just wait for 1 second. So this one, feed rate we just calculate, but material removal rate equal to feed rate into this one thickness of the sheet into this one, as I just given the uniforms about two sides. So 2 sides into 0.5 means it's about how much? 1 millimeter. Okay. So you can see like this means that means this is how much? 1. So here 0.5. So entire thing is 2 millimeter. So this one into which one? 5 millimeter. Okay. 5 millimeter. 5.0 into 2. So 220 millimeter by minute into 10 millimeter. So much 200 will be the answer. Okay. I think so I got the point. So next one is we are just seeing about the ultrasonic machine. I will just show you the my net is not working. Okay. So you can see this is ultrasonic machine. I'll just show you one. See, it's just vibrating so much faster. So as it is been vibrating so much faster, it gets blended. It means it gets mixed. So you can see. So this is ultrasonic machining. Okay. So generally you can see each and everything, the force will go up and down. You can see while it's been force, a slurry of abrasive and water must be flown. So that's why the small particle which comes out. Okay. And the slurry and abrasive will hit here, and due to this heating, each and everything will just come out. Okay. So vibration you can see the 90 to 25 kilohertz and amplitude is this much. So in electrochemical machining, one by one atom will come. In ultrasonic machine, 15, it means about 15 abrasive material, 15 also will just come. So 15 particle we just take at the one time, okay. So workpiece not, yes, definitely in this workpiece can be non-conductive, and also we can do non-conductive material if electrical conductive. If generally electrical we can just go for electrochemical and as well as the electro discharge. So 50,000 means it means one sand strikes about 50,000 times. So at using striking we can just take the material outside. So in ultrasonic machine, a tool of desired shape vibrates at ultrasonic frequency 19 to 25 kHz with an amplitude around 15 to 50 microhertz over the workpiece. So generally the tool is pressed downwards with a feed force F. Between the tool and workpiece, the machining zone is flooded with a hard abrasive particles, generally in the form of water-based slurry. Okay, ultrasonic machining is as the tool vibrates over the workpiece, the abrasive particle acts as an indenter, as definitely, and indenter both the work material as well as the tool. The abrasive particle is as and so that the work material is even the work material lack ignitions and ignition and propagation and brittle fracture of the material occur. Okay, brittle movements easy, but ductile is definitely in the ultrasonic ductile is not possible because ductile is has a lot of elastic behavior. So that's why ductile is not possible here. So generally in ultrasonic machine they used to ask just direct questions. So instead of going upon it means a lot of bigger question, they will ask mostly of direct questions. Okay. You can see ultrasonic is mainly used for machining brittle materials, which is poor conductor of electricity and thus can't be processed by electrochemical as well as electro discharge machining. Okay. So ultrasonic machine as full in understanding, you can see this is the material removed. So generally they will just give this thing in the question itself. Okay. So okay. Next one you can see process parameter, amplitude given, frequency given, feed force. So these are a little bit of extra things. So you can see effect of machining parameters on metal removal rate. Okay, so I'll just explain this graph. So metal removal, and you can see this is a feed force. Okay, while the amplitude has been increasing as well as the metal removal rate will increase. Okay, if the feed force increases, definitely the amplitude will be also increases. Okay, F is feed force, yeah, and small f is feed force and small f is frequency, and as well as when if the frequency increases, the metal removal rate will also increases. Okay, and same well as when the diameter, it means diameter of the slurry increases, it means also it has a limit. Okay, like this. So the diameter you can see here. Okay, but after that it's be suppose if it's given a huge diameter means definitely the metal removal rate can't occur. Okay, so amplitude increases, the frequency also increases, is be linear. So next one, metal removal rate, if frequency increases, you can see frequency increases, the metal removal rate also increases. And simultaneously if the metal removal rate we need to take out means we have to just give the required material. It means aluminum oxide has this much metal removal rate, but you can see boron carbide means this much it has been as a capability to take out. Okay, so it depends on each and everything. So you can see in ultrasonic machining the material removal rate is plotted function of feed force also with the increasing the feed force. Yes, increases linearly. See, with increasing the feed force only they are asking. Oh, see, yes, definitely increases and later on decreases. Chai. Feed force first increases, later on decreases. Okay. Wow. So because after a certain limit it tend to decrease. Good question. Ultrasonic machine will be like this. Okay, so definitely transducer horn will be there. The basic mechanical structure of ultrasonic machine which is similar to drive press. Okay, between material. Okay, the table can be turned down, lower or raised to accommodate work of different thickness salute derivatives. And the feed mechanism to provide the downward feed force on the tool. Okay, and the transducer which generates ultrasonic vibration, the horn and the concentrator is mechanical vibration. Okay, so here most of the things is transducer, power supply, abrasive tool holder and tool. Next thing is ultrasonic vibration are produced by transducer. The transducer is driven by suitable signal generator followed by power amplifier. Transducer for an ultrasonic machine works on the following principle. One is piezoelectric effect, magnetostatic effect, electrostatic effect. Okay, in this which one is good? Magnetic is very good. Okay, and the piezoelectric effect, the vibration is so much, but the force is not that much so much accurate. It is magnetostatic effect, both are good. Okay, electrostatic effect, vibration are not so that much. Will magnetostatic transfer are more popular and robust. Okay, you can see in this which one piezoelectric effect is so much valid, ultrasonic. So next one is you can see tool holder horn. So its function is to increase the tool's vibration amplitude and to match the vibrator to acoustic sound. Okay, it must be concentrated of the metal with the good acoustic properties and to be highly resistant to the fractive characteristic. Okay, molar and titanium are good acoustic properties and are used together with the stainless steel, which is cheaper. Okay, so which one? Monal and titanium alloys with the stainless steel. Okay, we use this one, often used together with the stainless steel, which is cheaper. Okay, it should not have fatigue load. Okay, so next one you can see tool should have concentrated from relatively ductile material. Yes, mostly the tool should be concentrated from relatively ductile material. The harder the tool, the faster the wear and tear occur. Okay, so mostly the brittle material if used means definitely the tool removal rate will be so much high. So limitation, yes, low material removal rate, rather high tool wear rate, low depth of hole. Okay, definitely. So application you can see used for machining hard and brittle material, metallic alloy, semiconductors, glass, ceramic, carbides, ceramics are very so much important. And you can see machining, wire drawing, punching and small blank dies. Okay, you can see ECM can easily fall to glass, silicon and germanium. The tool in ECM is generally uses steel. Okay, okay, see glass. Okay, glass with ultrasonic. In ultrasonic machine, the material removal rate will be higher for material with the material removal rate will be higher with low toughness only. Okay, yes, low toughness is brittle material because generally we use the brittle material as a tool. Okay, you can see the tool should be brittle and it should not be very hard. Okay, so low hardness goes for brittle, high hardness, high toughness goes for ductile, low toughness goes for brittle. Okay, high ductility and high fracture strain. Okay, this kind of things won't occur. Okay, so you can see increase in dia. Okay, first increases then decreases. See, okay, average jet 3000 which is achieved by average actions. I think so. Average action vibration. The material removal is achieved by. Okay, next one is affected by high frequency sound waves. I just showed you. Chemical machining process. Electrochemical now. Okay.
away material from work surface. Such chemical solution is called etchant and is highly corrosive. No separate cutting tool, shape tool or similar device is used here. On the other hand, in electrochemical machining, material is removed by ionic dissolution but under the assistance of electrochemical reaction. No corrosive etchant is used here. Instead, a suitable electrolyte is employed.
So not a bigger thing, it's just a simple thing only. Chemicals are used to resolve metal, masks are used to control attack. Most commonly it is used for circuit boards and plates for printing. Cutting speed is so much very lesser, okay. Next one is chemical machine. This is photochemical. So photochemical method is using chemicals produce high precision parts. The process is called as photo etching or chemical method. This one, okay. So coating on the both sides of the plate, photo is okay, this is spray metal, okay. Okay. These are the basic things that we use just to knowing the working, okay. And this is also one of the most interesting thing, because photochemical etch factor depth of cut divided by undercut, okay. Depth of cut divided by undercut, depth of cut divided by undercut, okay. Suppose in case of chemical machining it's different, depth of cut divided by undercut, okay. Sorry, undercut divided by depth of cut, okay. That's it in chemical machining. So in sometimes in the question also they may ask like this kind of questions to it, okay. So maybe in the next class we'll just finish the entire chapter. Okay guys, that's it for today's video, and I'll just see you in the next video. Until then, take care, bye bye, have a good day.